Leetcode problem, add two numbers. So basically, let's see what is the problem. So it is saying you are given two non-empty linked lists, okay, representing two non-negative integers. Okay, the digits are stored in a reverse order, and each of their nodes contains a single digit. Okay, add the two numbers and return the sum as a linked list. Okay, you may assume that two numbers do not contain any leading zero except the number 0 itself. Okay, so we can get the 0 itself also. So basically what is saying, two numbers are given and each node in the form of linked list, and each node is representing basically the digit of those number. And also one of the thing is like these are in reverse order, which means like it is 2 4 3. So this number is basically 342, and here you see 564. So this number is basically 465. So if we add them, yeah, so if we add them, we are going to get 807, and that too we have to return in the form of linked list only and in the reverse order itself. So I mean, this is a simple question. It's just if you know about the linked list, how to operate on them, so it will be very easy. So what basically we can do, we can traverse both the linked list node by node, okay, and keep adding it. And also we know whenever we add two numbers, we are going to get a carry, right? Like here in when we did 6 plus 4, we got 10 and we carry 1, right? So this logic of carry also we need to see, right? And yeah, and also like there could be multiple ways of solving this, like whether we want to create a new linked list or we want to use the existing linked list. If we create a new linked list, it will be like we are going to use more space, right? If in the second method we can use these two existing ones only, right? But in that scenario we have to take care of few things, like when we are reaching the null of the linked list, and all those cases we need to see, right? Okay, so hope the problem statement is clear. I think there is not much to explain here. Directly we'll jump to the code and we'll see the logic there itself, right? So here is the Python code for this problem. So basically what we are doing here, right? Let's see. So in this method I have tried to update the existing ones only, because the second method, like of creating a new linked list, that is very straightforward and easy, right? You can try that also. So here we'll try to update the existing one itself, and the number of lines of code may look more. You can try to reduce it, right? So let's see. So here I have initialized the for the carry, right? The carry which we are going to get, and this is like our final answer. And this is like previous for the previous node, because when we reach the null of one of the linked list, still we are going to get, right? We might be having the, let's say this is a scenario. So when we reach the end of one of the linked list, let's say I was populating this one, if we reach the end of this, then what we need to do, we need to point to the next node, right? So for that you need to maintain a previous node variable also. Let's see how it is doing. So while L2, so why so basically what I'm doing, I'm populating all my the summation whatever I'm doing in L2, right? So here you can see L1 and L2 are the two linked lists which they have given. Okay, so let me erase it. Okay, so let's assume these are our L1, L2. Let's see. Okay, so here it is saying initially I have initialized sum equal to 0, and L1, if we are populating in L2, then there is a scenario, right, where L1 is short and it got end earlier only, like in this case itself L1 will get end. So for these two we don't need the L1 component, right? So we need to keep checking like whether L1 is existing or not. If L1 is existing, then only we will increase this S, right, our summation, and whenever we increase it we need to move to the next node. So very simple, right? And L2, so if L2, I mean if was not required because already we have checked here that L2 exists, but still I mean you can ignore this if so. Here what I'm doing, when once L1, like if L1 is not there then S will be 0 only, right? Now we need to add the L2 part. So we are adding the L2 part, along with it we am adjusting the our carry part. Why I'm adjusting it here not in L1, because L1 may not exist, but we are sure that L2 is existing here, because in the while part itself it would have not gone inside, right? So now yeah, so when we added the carry part and these digits, so maybe we are going to get 2-digit number, right? So for that we need to take the unit position number. So that can be done by taking the modulus 10, right? And the carry part, like the remaining number, like we got the number, let's say 18. So when we did modulus 10, so we got 8, and when we divided it by 10, so basically 1.8, and it will take the integer part because it's the integer division. So we will get 1, right? So we are able to calculate our carry also, and this P is like just for maintaining the previous node, because now L2 is going to get to the next part, so we'll store its value here. This is important for handling the case where let's say L1 is bigger and L2 is smaller, L1, L2. In this case, when we are going to hit null, right, when L2 will become null, then this P only will help us to point to the next node of L1, right, because we want to return a linked list, right? So it has to be continuous, right? So how we will know which is the next node, right? So for that you will see like how this P is helping us. So here you see, so while L2 is there, it will keep populating the sum. Now if let's say this was the case, then what will happen? Then there will nothing be to calculate except that let's say still carry is not 0, carry is still 1, but these were the L2 digits. So these are calculated but carry part is remaining, so we need to handle the carry part. And if this is the scenario, then we need to handle the remaining digits of L1, right? So for that, handling the remaining digits of L1, I run one more while loop here. Okay. Okay. So now simply calculating the sum of the L1 plus the carry, and then again doing the same logic of finding the unit digit and the carry part, and then and yes, we are populating the in place of L1 itself, right? Let's say this node what we are handling currently, so I added the carry and stored it here only, right? And gave C is now storing the next carry part. Okay, and here also I'm maintaining a one previous uh, previous. So now for that this becomes very important, right? P dot next should become L1 when the L2 ended, right? So now now it's like going to be a uh, new linked list. So p cannot be like, what should be the like p, right? Because why this p will be needed? P will be now this needed to handle the carry part, as you will see later on, right? And if it was this case, then to yeah yeah so if this was the case, then in the end p will be here, right? And p will be here. So what we said, that p dot next is equal to L1 and L1 will be null, so it means this will point to null. And if this was the case, then p will be here, it will point to the next node which we need to handle. So exactly we can know like uh, which we want exactly, like to maintain a p, right? And in this case we need p, so that at the end we want p to point to the last node so that we can handle the carry part. So here you can see, if c is greater than 0, like still it could be possible scenario, right? So what we are doing, p dot next is equal to, we are creating a new node and giving it the value of c and then finally returning the answer. So important thing, the question looks easy, but just important thing is to think about these cases basically, right? Like there could be two cases like L1 and L2, like since we have only two lists, so how we are going to, what will be the input and what is the expected output, and whether our code is able to generate that or not. So like the two cases I handled it, like when L1 is small, when L2 is small, right? And how to handle the carry part basically, right? So this was submitted, and as you can see the result here was 100%, it's fine. And if we talk about the space complexity, so as you can see I haven't used any extra space or right there. So our space will be O of 1 only. And if we talk about the time complexity, it is also like O of n only, right? Because we are just traversing over these nodes, right? We are not doing any nested loops or recursion, anything like that. Okay, so hope this was clear. Okay, thank you.